Hello students and welcome back to my channel Infinity Minds where maths is made easy. Today we are going to take up the second chapter of Ganita Manjari linear polynomials second part. Okay, let us continue. So this is exercise 2.5 and 2.6 we will be taking up talking about linear relationships. Okay, and you also have graphical representation of linear relationships. It is a relationship between two variables like this. Here it is written y is equal to ax plus b. So x and y are your two variables and they are dependent on each other. You remember the input output process machine that we had talked about. There the example taken was 2x plus 3, right? 2x plus 3. So as per the value x is given, it was like this. You had the function in between. What value x takes, the value of y will be dependent on that, and that was being termed as function. As I had told you right in the beginning, these are new terms to confuse you, but we don't have to do that. Okay, so now this way it was a linear growth, linear decay we have studied. Similarly, it is also to be looked upon as linear relationship between two variables. Let's move ahead. Let's try and understand. You will feel better then. Question number 1, exercise 2.5. A learning platform charges a fixed monthly fee and an additional cost per digital learning module accessed. Okay, it's an online fees you are giving. A student observes that when she accessed 10 modules, her bill was rupees 400, and when she accessed 14 modules, her bill was rupees 500. If the monthly bill Y is dependent on the number of modules accessed X, according to the relation y equals to ax plus b, find the values of a and b. Okay, so now what have you understood? That number of modules is x, it is variable. If she is accessing less modules, the bill is 400. If she is accessing more modules, the bill is more. So this is kind of your direct proportion thing. More the number of modules, more is the bill. So yes, x and y are directly related. Of course, yes, they are. So if she's accessing more modules, if she's doing, so she is paying also more. Apart from that, what else is there? What is B in the case? B is the fixed monthly fee which the platform is charging. Like you also have this example also shared in the textbook that if you have access to your this internet modem which you put up, so putting the modem in is one fixed fee, and apart from that the amount of data that you use, accordingly the bill will come. If you access more of data, internet data, you may pay a higher bill. Yes. So similarly, there is also this y equals to ax plus b, where y is dependent on x, but in a way both are interdependent, one can say. And a and b, what are they standing in this question for? A is the number of modules the person is accessing, and b is the fixed price. Okay, let us go ahead and try and frame equations. So if 10 modules, it shall become a x takes the value 10 as the modules is x. So 10a plus b will give me 400, and 14a plus b shall give us 500. When x is 10, y becomes 400. As per the value of x, y will be made, and so on. So we are able to create two equations. Yes, we have not solved equation in two variables. We have solved polynomials in one variable, agreed. But at the same time, equations given are also two. Okay, it will be possible for you to solve two equations in two variables, but with the help of two separate equations, then you can solve. Okay, the equations that you will get would be of this type, not impossible situations. Kindly notice there is one fact which is common. There is a common thing which is appearing in both of them. So let's see if you mark them as equation 1 and 2. These are the equations you create from the statement of the question. Subtracting 1 from 2, whichever way you subtract, say 500 minus 400, LHS will get subtracted from LHS, RHS from RHS. Now when you subtract 14a plus b minus this, b will get subtracted from, it is a 14a plus b. from which you subtract 10a and you also subtract b. So the b is cancelling. It is 14a minus 10a which is left, which is 4a. Single a will be 25. One of the variables you will be able to get rid of. It will ultimately, equation will come into single variable only, which you have learnt. So getting the value of 1, you substitute in any of the given equations and get the value of the other variable. Substitute 25 10 times 250 and hence B comes as 150. Okay. So as such, the question was saying find the values of A and B in case statement is asked, or otherwise also you should know. So what is B? 150 rupees is the standard fee which the platform is charging. That whether you use the module, whichever number of, whether you use less number of modules or more, even if you don't use anything, even if you don't use, but the charges will have to be paid. So 150 is the fixed price. And if you are using 25 modules, so 10 modules, so sorry, 10 modules for 25 rupees is the price of accessing a single module. 10 modules will be 250 rupees, another 150 makes it 400 rupees. Clear? Let's go to the next question. Question number 2, very, very similar. In fact, this most of you will be able to relate. I in fact wanted to take this one first. Question 2, a gym charges a fixed monthly fee and an additional cost per hour for using the badminton court. Clear? So person is enrolled himself in a gym. You have to pay the gym charges, whether you use the gym or not. Even if some of us, when sometimes we become very health freak, we join. So you have to pay the fixed charges, and if you use another facility, you will pay extra. A student using the gym observed that when she used the badminton court for 10 hours, her bill was rupees 800. When she used it for more hours, 15 hours, her bill was 1100. Naturally, the bill has gone up. If the monthly bill Y depends on the hours of the use of the badminton court X, according to the relation Y equals to AX plus B, find the values of A and B, right? Very similar. Value of X shall calculate the value of Y. X is the number of hours one is using the badminton court and Y is the total bill being paid. So what are A and B? What are A and B after all? Okay. A is, they are the charges for the badminton court, and this is the fixed charge, which the gym monthly fixed fee. Let's find out what equation will we get. As X becomes 10, the bill is 800 when he is using the badminton court for 10 hours. So it will be 10A plus B equals to 800. This would be 15A plus B equals to 1100. Same thing I told you, you will get a fixed. You can subtract. So this you will get 300. Here you get a 5A. So single A becomes 60. Putting 60, 10 times 60 is a 600. 800, 600, this becomes 200. So the fixed bill gym charges are 200 rupees and the per hour charges of the badminton court is 60 rupees per hour. Clear? We'll go to the next now. They are all very similar. Question number 3. Consider the relationship between temperature measured in degree Celsius and degree Fahrenheit. Children, the thermometer that we have with which you measure the body temperature, if you notice, it has temperature of both the kinds. Degree Celsius also, and simultaneously one is above, one is below the same says thermometer. There is degree Fahrenheit also printed. So degree Celsius is equal to A degree Fahrenheit plus B. I mean, if some temperature is shown, the normal body temperature 98.6 is degree Celsius. And similarly, Fahrenheit can be calculated. Find A and B given that ice melts at 0 degree Celsius and 32 degree Fahrenheit. So when that ice melts at 0 degree, which we are very commonly we are aware of it, that is at that very moment, what is the temperature the thermometer would show in the Fahrenheit? It would show correspondingly 32 degrees. And similarly, when water boils at 100 degrees Celsius, the corresponding mark for Fahrenheit is 212 degrees. Now, the hint given is children have the problem solved. In fact, the entire problem is solved. The hints are normally useful. which are always provided. They tell you they help you the most, but yes, they are provided in the text, but in tests don't expect teachers to give you hint. When degree Celsius is 0, Fahrenheit is 32. When degree Celsius is 100, Fahrenheit is 212. Use this information to find A and B, and thus the linear relationship between degree Celsius and Fahrenheit. Now see, the only thing that has gone twisted here is that y is equal to ax plus b. That thing has changed to this. Degree Celsius is equal to a degree Fahrenheit plus b. Now what are you understanding? The variables x and y have got replaced by degree Celsius and degree Fahrenheit. Not a problem. Okay? Yes, writing wise it's slightly not the usual form, y equals to ax plus b. As of, you would say we are not used to, but soon you will get used to writing. Once you solve so many questions, you will get accustomed to writing, y equals to ax plus b, because all questions are full of this. And on the contrary, this would be different writing wise. But nonetheless, the concept goes the same. Let's see. So this is the main equation. Given Fahrenheit, comma, so when Fahrenheit is 32 degree, when the ice was melting at 0, this was 32, vice versa. We will simply put it in our equation of y equals to ax plus b. That c is equal to af plus b. Substituting 0 here, this will become 32a plus b, because we were told this is at 0 degree, this is 32. Y equals to ax plus b. Second, when this is 100 degrees, so 100 is equal to 212 plus E. Again, your B is common. You can subtract 100 minus 0, 212 minus 32, which is 180. Yes, we shall get a fraction answer, not a problem. 100 by 180, 5 by 9. Once you get the value of one variable, substitute it in any of the equation to get the value of the other variable. Now this is 32 times, print wise it has gone like this, but 9 will come in the denominator, and if they can reduce, supposed to, but as of nothing is happening, it will be 5 times 32, that's a 160 by 9. Okay, but solving for B, it will go that side and it will become negative. So A becomes 5 by 9, hence the relationship will be given by same degree Celsius is your equals to A degree Fahrenheit. So degree Celsius, your final answer will become A, which is 5 by 9 times degree Fahrenheit, and B, which is minus 160 by 9. It is absolutely correct if you leave your answer here, or else if you notice 5 by 9 can come out common from this. Numerator 5 is coming, denominator 9 is coming. In the bracket it is degree Fahrenheit minus 9 is already out, 5 shall go 32 times. This is just a matter of, that we say simplify and write your answer. So you can further simplify taking out common. Not necessary, but yes, it completes your answer. It appears in a finished manner. Okay. That's about all. We shall now move to the graphical representation of such equations. Y equals to ax plus b. In our times, few years back, it used to be y equals to mx plus c. Now they have changed it to ax plus b. Nonetheless, absolutely same. We shall move ahead now. Okay, so visualizing linear relationships, y equals to ax plus b, this straight line. Yes, we shall now learn how to plot this on a graph. Let us get accustomed to certain new terminologies. A represents the slope. If your value of A is positive, mind it, all the questions that we did, A was very much only positive, but yes, we will have negative A also. Y equals to ax plus b. If A is positive, A is greater than 0, that is called a positive slope. First of all, the term is A is referred to as a slope. Positive slope or negative slope. Positive will represent growth. So it's all interrelated, and in a way they are all similar things. We first started with the situation questions of your linear growth only, and now we are coming to the graphical representation. Graphical representation of a relationship, and relationship may be either relationship between the two variables, but either it's going to be a it's a growth representation of a growth or a decay. The things are declining like depreciation, or it's a growth in something which we had done couple number of examples. I don't need to repeat the pocket money or growth of the plant and so on. Okay, so quickly I repeat concepts so that you learn within the class. A is your slope, positive or negative, linear growth or linear decay, negative slope, decay, and so on. Now coming to B, yes, absolutely no new terminology. B represents the y-intercept. Simply learn up this word, children. B represents the y-intercept. Distance from origin where line cuts the y-axis, its coordinate would be 0, comma b. If b is equal to 0, if there is no b, of course, if the b is 0. Like in that gym charges, there's no fixed charges. Gym is free. Free, this is gone, this is 0. Y equals to ax will be left. Of course. It passes through the origin. All this we will realize, okay? For all these notes and all, comment in the, just write PDF notes in the comment section and I shall directly mail them to you. Let's understand it more by actually plotting the graph. Parallel lines, yes, you can read through them later. I have put the notes, but all of this is useful and we will just realize them. Let us not just learn them and accept them for the fact they are written. We shall understand them. Okay, going to the next. Linear relationship and graphs. A linear relationship between two variables x and y is represented by y equals to ax plus b. A is the slope. The slope determines steepness and direction, children. A positive slope will give growth, and the graph for such a slope would be this kind of looking. Every time when you will plot, that's the kind of shape you would get. And when the slope would be with negative a, when you have a decay slope, the graph for a linear decay, the slope line, the graph line would be like this, going down. A slope, it determines the steepness and direction. So direction is clear. Positive slope direction is like this, left to right, upward, downwards. Steepness, yes, this we will understand more after doing questions. B is B is the y-intercept where the line cuts the y-axis at 0, comma b. Linear growth versus decay. Growth increases by a fixed amount, positive slope. We have done this. Decay decreases by a fixed amount. Okay. Without wasting time, let's move ahead and see how graph can be plotted. I somehow find plotting graph really interesting. Let's see. So that's the first question of the question I haven't printed, that draw the graphs for the following lines, for the following relationships of x and y. And also they have asked you, what can you conclude or observe from the graph? Okay. So it's the first time for you. Of course, you can't observe. I will first be guiding you as to what is to be observed. And in fact, similar observations you are to make in all the following graphs. First of all, let us see how a graph should be made. Children, you must practice making. More you practice, you gain speed. So it's a graph sheet. All this you've done in the first chapter, coordinate geometry. Yes, I know that. Let's just recall a horizontal line, x-axis, right side positive x, left side negative values of x dash, which is called xo(x dash, and vertical is yo(y dash). Positive y-axis, numbers above, negative numbers below. First quadrant, second, third and fourth. But as such, there is not much usage of the quadrants, in the sense not as much as your first chapter, no, for as far as quadrants are concerned. But yes, way of plotting points must be clear. I shall be revising them in this topic with you. That logic concept will continue. How to point plotting. X comma y coordinate, we plot a point, children. Right? We'll just see. Let us see what is there. First equation is y equals to 4x. See, I've made three boxes. Y equals to 4x. Say I label this y equals to 4x. This is one. This would be, there is a second. Every graph line, every relationship will have a separate point plotting. This is like plotting three graphs in a single graph, children. Okay. Now y equals to 4x. In the table, let us write x and y. Any value that, and we just talked about a relationship. If I give any value to x, see, you are supposed to give any value, and accordingly that input output process we will actually actualize now. Okay, that any value I give to x, my y is dependent on x. Okay, y is dependent on x. If I give x value 0, 4 times 0 is going to be 0. If I give the value x1, if x becomes 1, 4 into 1, 4. If I say x is 2, 4 into 2, 8. We will learn. And this x comma y coordinate is the one I am talking about. When we plot, we will plot 1 comma 4. We will plot 2 comma 8. We will plot 0 comma 0. Okay. Minimum plotting 2 points is compulsory. I always suggest my students to plot 3 or more points. Okay, it's not compulsory. Minimum 2 points you have to plot. You have to be careful. Calculation can just not be a problem for such easy numbers in a class 9 student. Okay. Again, we will give x and y. Now, this is separate for this second relationship. Always try and give easy values. If you have the choice, then why not? X0 you can always try for. X is 0, again y will come 0. X is 1, y is 2. X is 2, y is 2 2s are 4. Let me quickly complete the table. Oh, x is equal to y. X0, y0, x1, y1, x2, y2. Okay, no problems. We shall do this. Let us continue and go to the next slide. Now, as you start plotting, what I am telling you, we have to plot 0 comma 0. If you plot 0 comma 0, then we got the point 1 comma 1. Then we got the point, so 2 on the x-axis and 2 on the y-axis, 2 comma 2 and so on. And then this should be joined using a scale and a pencil. This way, joining of points shall give us the line representation, graphical representation. You have represented this particular relationship, y equals to ax plus b relationship. The cases that we are doing, the y-intercept b is not present, mind it. It is y equals to only ax, the equation that we are representing right now. You must write the name of the equation on the line that you draw, the graph line that you have created. And similarly, the next two graph lines shall be plotted. Just have a look. When you plot 0 comma 0, when you plot 1 comma 2, 0 comma 0, 0 comma 0, 0 comma 0. I have plotted the same point 0, 1, 2 in each case just to make you realize. You can as such put any points. All the three lines pass through 0 comma 0. Fine. Our job is not to really see through that, but eventually we are to conclude certain points. Let us first start plotting. If the first line y equals to 4x, I have plotted in a red color. Yes, you will first all plot it with a pencil scale, but eventually color them. Preferably you must color. Right, coloring is optional but is certainly suggested. Writing the name over the line is not optional. That you have to make sure you do it. You make 3 blank lines, that will not be sufficient. Which line is representing which relationship, right? So y equals to 4x, say red one, 0 comma 0, 1 comma 4, 2 comma 8, it passed through. Do the point location and join the line the way I just showed you. Next we come to y equals to 2x. Again 0 comma 0, 1 comma 2, 2 comma 4, and the line passes through. Third, y equals to x, 0 comma 0, 1 comma 1, 2 comma 2, line passes through. Clear? So how to calculate the point locations? Second, step 2, how to plot plot the points and join them with 3 different colors and writing their name. That's about all for your graphical representation. Easy, not a problem. You have done very similar in coordinate geometry chapter. Just an extension that three of them are together and you have to join the points. I hope that's absolutely clear. Moving to the last part of the question, what all can you conclude? What are your observations after all? Don't you observe that they all pass through the origin? Right? That can be one. There is another observation to be made, children. You remember we talked about steepness. We talked about steepness. Y equals, it's not by hit and trial or just like that. Y equals to 4x is standing far above 2x, is standing far above 1x. After all, y equals to x is a 1x. 1x, 2x, 4x. I'm basically trying to say, had there been a 3x line, it would have come between 2x and 4x. Greater than 2x, less than 3x. Had there been 5x, y equals to 5x, it would come far beyond 4x. So as per the value, the steepness will be there. What else do we observe? They are all positive slopes and there is linear growth graphs which have been there. Okay. Had there been y equals to half x, it will go down. Okay, let's move to the conclusion points. All lines of the form y equals to ax where b is 0. What are we observing? That they all pass through origin. They all pass through. The value of a determines their steepness. Larger the a, steeper the line. Yes, positive slope, it is going to be a growth. Even that, if you want to note down as an observation, it won't be wrong. But it determines the steepness. That particular point is a must because it is somewhere unsaid comparison that is taken up, because if you're plotting more than one line, three graph lines are being plotted. So it's a kind of a comparison. Clear? We shall move ahead and practice more questions of the same kind. Y equals to minus 6x minus 3x minus x. What do you observe? Negative slopes, children. First thing which you should observe. The y-intercept, b is 0. Slope is negative. Clear? These two should be clear-cut observations for you. Plotting the points. X, y, x0. For the equation y equals to x0, y0. Second equation, plotting the values of x and y, x0, y0. Third equation, plotting the values of x and y, x0, again y is 0. x1, y is minus 6. In the second equation, x is 1, y is minus 3. Third one, equality, x is 1, y is minus 1. Let's see how the graphs can be plotted. Absolute reverse direction. Downward looking negative slopes. Downward looking graphs will come. They all will pass through 0, 0, minus 1, 1, then minus 1, 2 and so on. Labeling them with different shades and marking the lines that what they are representing. Conclusion points. Y equals to ax, b is 0, they all pass through origin. Negative a means slope is downwards. Larger a, steeper downwards. Absolutely same in the opposite direction. Every time the growth graph will be like this, the decays are going to be like this. Secondly, comparison without, if between them, larger the value of the slope, steeper it is going to be. And similarly here, as they are falling, the steeper downward slopes will also be, there would be comparison of them to be who is less steeper, who is more, which is more and which is less. Going ahead. Now, one positive, one negative slope. So try and see if would they pass through 0, 0? Yes. It's a mixture of the previous two parts. Y equals to ax form only. Again, y equals to ax, and the second one is y equals to minus ax. Both carry the y-intercept 0, positive slope, negative slope. But the equations of these types we have already studied. They will pass through the origin. They are bound to pass through positive slope, One is the growth, graph of the growth. The other will be the graph of the decay. Beforehand also we can analyze, even by looking. This much should eventually strike you after you practice. Of course, there's going to be a difference, children. I have done them over the years. You will be doing for the first time, but just letting you know how to think over it. So point plotting can be done, and if you see, they both will pass through 0 comma 0. If I give 1, it is 5 times 5x, 1 comma 5, 2 5 2 comma 10, and the same points will come reverse. If I put a 1, but it will be minus 5. If I put a 2, it will be minus 10. So both will make absolutely the same lines, but in the required directions as per their slopes. Both line pass through origin. One is slope upwards, one is down, one is decay, one is growth, slope of growth, one is your graph of growth, one is decay. Same magnitude, same steepness, but opposite direction. Now, if you have to compare and talk about the steepness factor, that would be termed as opposite direction. Earlier we were talking about greater the magnitude, more steep, less steep. Now it is same steepness that we will, because in this question it was both were 5x and 3x, 5x and minus 5x. No, it was y equals to 5x and y equals to minus 5x. So the magnitude was same. Had they not been, then we won't say. But they are going in opposite direction. Yes. One is of upward, downward, growth, decay. All these you can put in the observation conclusion column. These are after all your observations. So let's conclude visualizing slope a y equals to x. Such all of them, they always pass through origin. There is no choice or doubt in this. That is always there. If the slope is greater than 1, the line is steeper than y equals to x. See, y equals to 1 y equals to 1x. Y is equal to 1x is your balanced, the basic equation. If you increase the magnitude 2x, it will go upwards steeper. If you decrease, if it is half x, it will come below. Comparing to the blue line, y equals to 1x, 2x will be equally double with the double magnitude difference it will come, and half x will be absolutely downwards. And so now going over to, so this was y equals to ax. Similar observations can be done for the negative side, okay? Complete notes you will get as you will DM in the comment section. Now moving to the second part of variety of the graphs, where we started with y equals to ax plus b. See, children, logic wise you're not gonna do anything different. That was one step less. The value of b was not there. B was 0. And there were certain type of conclusions. If you see, conclusion points were repetitive. Observation points are in a way are repetitive, that they all pass through origin and so on. Now moving over to this, of course, there is a y-intercept, b, and let's see, do they pass through origin or not? The first common point which we were continuously doing, pass through origin, pass through origin. Let us see whether they passes through origin or not. So again, there are three equations. Y equals to 3x plus 1, 3x minus 1 is my first equation, for which I've created the value calculation box. Y equals to 3x. Can you see? Y equals to 3x is my second equation. And then y equals to 3x plus 1 is my third equation. Values for x and y. If so, our favorite, putting 0. If I put a 0, 3 into 0 will be 0. Minus 1. No, y will not come as 0. Y will not come as 0. You remember when we talked about y-intercept, you were given one point. It passes through 0, comma b. It cuts the y-axis 0, comma b. We had written this. This is there in the notes written. So you understand better once you do it. 0, comma minus 1. That is this case. But in every case, you will realize that where you have the y-intercept, it will not pass through the origin. That is what I am trying to convey. If I put the value of x as 0, 3 times 0, whatever value you get, but not it will pass through origin. And on the contrary, so this is y and x. Y equals to 3x, no y-intercept. This is that previous slope wala equation only. This would pass through. Y equals to ax equation passes through origin. But ax plus b, y-intercept equations, they don't pass through origin. Okay. Anyways, we'll put the point. Now, if I put the value x equals to 1, 3 into 1, 3, minus 1, 2. If I put the value 2, 3 2s are 6, minus 1, 5, and so on. If I put the value 1, 3 1s are 3. If I put the value 2, 3 2s are 6. If I put the value 1, 3 1s are 3, plus 1, 4. Next, if I put the value 2, 3 2s are 6, plus 1, 7. Let us see how the plotting can come. You should be able to try to visualize also. Tell me, children, how should it come? This should go right across positive growth slope. And let's see how they would come. Can you imagine? Let's start plotting. So, first of all, children, the typical green line y equals to 3x, our favorite positive. Yes, it will pass through origin and it will come like this. This should ideally change. I'll just change the color of the pen to make you explain better. It will pass through the origin. Coming to the red line or either the blue line, the ones which have the y-intercept. Y equals to 3x minus 1. As per the points we have taken, let us start plotting. If it's a 0, comma minus 1, 1, comma 2, 1 you will take from the x, 2 from the y-axis, 2, comma 5. These we plotted and we see and we simply plot and just check. Of course, they don't pass through origin. What else can we observe? And you can plot similarly for the blue line also. Label them. What are we observing? We are observing they are parallel. Is it always going to be so? Y-intercept lines, are they always parallel? Let's see. And if they are parallel, why are they parallel? With what logic are they parallel? Okay, can you think of? All lines have same slope. Okay, that's one of the observations. Lines are parallel, same slope. Okay, just see. AX, 3, 3x, 3x, 3x. All of them were y equals to 3x. One was minus 1. Here it is a 0. It's in a way you can write y equals to 3x plus 0. The y-intercept is not 0. 3x minus 1, 3x plus 0, 3x plus 1. They were at constant difference of the b. The b was at a constant difference also. Minus 1, you add 1 to it, you get a 0. You add 1 to it, you get a plus 1. They were differences of 1 unit each. The value of y-intercept. And the slopes were equal. Okay. Lines having equal slopes are parallel. This is one of the most important thing that you should in a way learn. I would suggest just learn this. Lines having same slopes are parallel, or when are lines parallel? If they have the same slope. Different values of BC. Now if the slopes are same, how can they give you the B also same value? Then the entire line will be same. Then they will that's the same line. Okay. Obviously B is going to be different. Having same slope, different y-intercept, something is going to be different. So lines having same slope. Slopes are same, but y-intercepts are different. Such lines are going to be parallel. A little above and little below, that is of course parallel. Negative goes below the origin, positive goes above the origin. Like if this is your this, first of all, y equals to ax has passed to the origin. That was in this case. The point is that if slopes are same, they are all going to be parallel to each other. They had positive slopes, that's why they are going in the growth direction. Otherwise, they would come like this. And if the y-intercept is minus, it is going below, and if it is positive, it is going above. So lines having same in slope, different y-intercept are parallel to each other. Most important, what you have to learn. Okay. We shall now move to another question. I think similar one is there to practice. So this is what exactly I've explained. If visualizing y equals to ax plus b, if we keep a fixed but b change, fixed a, slopes are same, b is shifting as per the value of b. Such lines are parallel to each other. Y equals to 2x. If negatives y-intercept below, positive y-intercept above. Same slope, different b, parallel lines. Another one to practice. What do you observe? Now you should be able to observe. Minus 2x, minus 2x, negative slopes. Negative slopes. Minus 3, y-intercept is present. Y-intercept is not present. And this is positive slope. And y-intercept is. It's a kind of mixture of all this. This was the first case you studied. These are the second cases. Second case you studied y-intercept positive slope. Now y-intercept negative slope. All the three variety has come. Can be teacher's favorite question where they want to test all your knowledge. Not a problem. Infinity Mind students can attempt everything. Okay, coming to this, start plotting your values. Give it a try. I hope just by looking you should see positive slope. We should be able to plan beforehand in our minds. Positive slope, a growth will come. Negative slope, so two of the lines will come like this in your graph. Clarity should be there. One growth line, two decay lines. They are, both of them are carrying equal slopes, negative. So they are going to be parallel also. Okay. I leave it up to you. Put your values, try them out. I'm sharing the result. You could see the slide also later. First, you try them completely by yourself. So, blue line, y equals to 2x plus 3. Positive growth. It is y-intercept is present, so cannot pass through origin. These two lines, slopes are negative. They will show lines of decay. Y-intercept is present, cannot pass through origin. Y equals to minus ax. Yes, of course, it will pass through origin because y-intercept is missing. Lastly, they both carry the same slope. They will be parallel also. Observations. These two have same slope minus 2, so lines are parallel. This has a positive slope, so different direction of growth. A controls the steepness and direction. B controls the vertical shift. Okay, clear? With that, we come to the end of the second part of the tutorial also, children. Don't worry, in a way, we are over with the chapter. You can be through with this. Go through both the videos carefully and practice questions. End of chapter exercise is now left, but the good point is that we have covered everything. That is your mixture exercise of the entire chapter together. But yes, it will give us a very good practice, and some very different questions are also there. Soon I will be uploading the video for the same. Okay, till then, keep practicing, study hard, and like and subscribe to Infinity Minds. Bye bye, take care.